Okay, so you have to have A, B, C in, sum, and C out, or let's say the carry out. Okay, so I have a look. Let's say you have A, B, carry in, the sum, and C out. So you have to just populate this 0, 0, 0. 0, 1, 1, 100, 0, 1, 1, 0, and this will be 1, 1, 1. Okay. So if you try to find out this sum, right? So what would you get? Here, what do you get? The sum is 0. Carry out is? Indeed. And what about this here? This is equal to? Okay. Carry out is? In here? Carry out? Carry out? Here? Yes? And? In here? Carry out? Okay. And over here? Here? What about this? Why 1? Yes, 1 plus 1 is 2, but it's 1, 0 there. Okay, we have already the carry in there, so that's why, okay? So that's that. So this is the sum, and this is the carry out. Well, alternatively, what you can say that your sum is basically A XOR B, and your C naught is none other than AB. Okay, so but that was actually in the previous scenario. So now let's try to draw the K-map. Okay, so the K-map is basically going to be for this sum. Okay, the K-map. And let's try to draw, let's say, something like this. Okay, there's various ways to actually construct a K-map, and okay, these are my inputs. So you have A, B, and C in, and here we can label 0, 0, 0, 1. Okay, 1, 0. Oh, sorry. Yeah. So it's basically 1, 1, and 1, 0, and here would be 0 and 1. So now you just have to substitute ones in all those places and fill up this table. So here what it's going to be? 0 in here, 1 in here, okay, and here, 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 1 and 0. So try to construct a equation for this scenario. So we have this, this, this. These are all isolated, isn't it? Right? So these are all isolated. Okay. So you can say it's quite isolated. And if we try to construct an equation which gives me this, so I can write this as A bar, B, C in, and then we have sorry, A, B bar, and then in my solution I have A bar, and then we have B and C in bar, and then we have A, B, C in, and then we have A, B bar, C in. Okay. So this is the scenario which we are in. So just like I have said earlier, that in the previous scenario for the half adders, we had the situation of a alternate, or let's say the alternate patterns, or you can say a checkerboard pattern. Okay, and it actually resembled an XOR gate. And in this case, since we have three components, so we can actually rewrite our own equation as such, which is same as, you see, I bar, B bar, C in is not prime there. I and C in is already primed, but B is not there. And in this case, all scenarios are not in prime there, but in this case, we have this scenario. Okay. So at some point in time, there is some element which, or let's say the input, which is actually primed or bar, you can say. Okay. So in this case, if we rewrite this equation, right, we will be getting this XOR pattern. Okay, so this will be basically I XOR B XOR C, or C in. Okay, so this would be our final equation, which is actually characterizing this sum. Clear so far? Right? So this actually characterizes this sum, and now if we try to work for C naught, okay, let's try to do for carry out, and if we want to perform the K-map for the carry out, we will be doing the same thing. Okay. Okay, and this is again AB, and this is carry in. Okay, so that's how we actually proceed. Now, once we do this, let's try to relabel our, or let's say, let's try to put all these ones in there. Okay, so if you are just oriented towards getting out the solution, and if you are in a hurry, just see where the ones are located, and that's it. So in this case, you have this scenario, isn't it? And the rest are 0. Okay, and very quickly you can draw these lines. Okay, and by inspection you will be getting the solution, I think, as your C naught is equals to AB plus B C in plus I C in. I think, yeah, that's correct. Okay. So this is the equation which I get. All of you confirm this? Yes? Can you guys confirm? Yeah, just by inspection, you try to look at all those, and then I think you will, first you have to go over that 1, 1 and zeros and all, and then try to rewrite the equation and just get to see which are the similar ones, and pick out those elements which are there, and you get AB, B, C in, and AC in. Okay. Now, we have already formulated our equations. The next step is basically design process, or design of the logic diagram. Okay. So at this time, what you have to consider that the sum, or let's say the sum secretary, consists of I XOR B XOR C in. Okay, so it consists of the XOR gates. Now, on the other hand, our C, or carry out, it consists of AB and BC in and AC in. Okay, so it consists of an adder and also an AND gate. Now, in terms of designing, in terms of optimization, we would like our circuitry to be as simple as possible, and we want to have, let's say, less elements in our circuitry, or let's say don't use multi kind of gates, but try to stick to one. Okay. So in other words, what I'm saying, you have to actually manipulate your equation and try to get to some specific solution which also for carry out consists of a XOR gate. Okay. So what you are going to do, okay, our goal in this case, okay, our proposed goal in this case is to have our C naught into this form. That's what I am actually indirectly saying. Our goal is to have our C naught equation in terms of IB plus C in into A XOR B. This is our goal. Okay, so I want this scenario to happen, and how I'm going to achieve it. Okay, I'll let you guys try first, and then we'll discuss it. So just to give you an idea that this is same as AB plus C in into A bar B plus B bar A. Okay, and you should be getting this kind of equation by manipulating the same K-map, which is this. You try to do some manipulation and you will be ending up with the solution. And you have to actually utilize some theorems which you have already learned. So I give you some minutes to do that, and then we'll discuss this as the final remark. Okay. Remember, you have to actually redraw your K-map. Okay. Try to redraw this and do some kind of manipulations whereby the elements, or let's say the terms which you are going to look forward to, are isolated, and you can incorporate the XOR gate. Okay, let me give you a hint. Try to generate equations for these scenarios. So generate the equations for that scenarios, and then I think it will be good. Done? Okay, so let's try to find out the equation. So in this case, our equation is from here to here would be C naught equals AB plus C in A bar B plus C in A B bar. Okay. So this is the equation. Now from here you have to move forward in order to match your goal. Okay, so I try to go on to our next page whereby I just rewrite this. Okay, so you have C naught equals to AB plus C in A bar B plus C in A B bar, and now you have AB, C in A bar B, and then you have A B bar. So you can actually manipulate AB plus C in is common in both, whereby A bar B plus A B bar is there. So this is actually an example of an XOR gate. So you have this is okay up till here. Now from here where I go? We cannot go here, right? We cannot go anywhere from here, isn't it? This is A, B, C in A XOR B. And what was our goal? Huh? That is our goal, right? So even if you try to prove, okay, let's say I want to prove that this is same as the previous scenario, then what we can do, we can go on forward, okay, simplify additionally, and it will be C in, right, into A B bar plus A bar B, and then open the bracket, it will be C in A B bar plus C in A bar B. So now from here, what you can do, you can just resubstitute and try to factorize. Let's say we try to get something of this sort, right? So if you go on from here, you will be able to see that you have AB plus C in into A plus B. That was your former equation, if you guys remember. Okay, so what I want you to do is this. Now we have already reached our goal. We have already know that this is the final equation. This is fine. Now from here, what you should be do is basically try to prove that this, okay, this is equal to this. Okay, this is equal to this, and try to prove that out. Okay, of course, there will be in the exams. There's always the case you have to prove that this particular portion is same as this, and definitely you will be using some kind of absorption theorem. Okay, if you guys remember the absorption theorem, you will be using it while you are doing some analysis. So try to prove this is equal to this. Okay, so I give you another 2 minutes to digest and work on. Start from here. So we will be having A into B plus C in B bar plus C in A bar B. Now here you will apply the absorption. Okay, by absorption you will be trying to reduce this particular components which are in the bracket. Okay. So try to reduce this and see what do you get. This will be A into B plus of course. Okay, so C in A bar B. Now reopen the bracket. C in A bar B. Okay. Now common in both is C in, isn't it? So C in into again we apply the absorption, isn't it? Yes? No? Maybe? Yes. Okay, so we have AB plus C in into A plus. Okay, so look at this. Where was I? This and this. Now we have AB plus C in A plus C in B. Okay, so this is basically carry out. So this is equal to this. Oh, sorry. This is equal to this. Okay, we have this C naught. Okay, which is AB plus C in A plus C in B, and the one which we calculated was this. So we have this here. C naught is equal to AB plus B C in plus A C in, or vice versa, whatever. I mean, the order doesn't matter. So you have this equal to this, isn't it? So here we can prove that this equation, okay, this equation is same as this. So in order to actually optimize our design, we can actually opt for this equation and then draw the logic diagram, and you will see that this diagram is a little bit, let's say, much cheaper than the one which we proposed, which was for this scenario. Okay? So we deploy the XOR gate in order to come to our solution, and what you can say that even if you get this solution, this is okay. It will be okay if you are able to correctly draw the logic diagram. That is okay, but we need some simplified solution, okay, which is a bit cheaper for us. So we have to actually opt for the one which I have derived, and in due process, you might have to actually draw the final ADA logic circuit, and this, or you can say this is the logic diagram which you will use. Okay, so this is the logic, or let's say full ADA logic circuit, whereby your C or carry out is none other than AB, okay, plus C in into A XOR B, and your summa circuit, or you can say the sum of everything, was basically a checkerboard, isn't it? So that was and this is the final solution for the full ADA. Okay, so this is what actually this lecture was all about, and I hope you have been able to get some key takeaway points from this full ADA theory, okay, and how you can use K-maps to actually finally design this logic diagram. Any questions? No? Okay, in my K-maps I might have gone left and right some of the orders, but I think the solution is correct, okay? So I usually got a hand of numbering, so sometimes I get confused, but whenever I do the K-mapping plotting, I get it correct. So that's the strategy which I use. But anyway, whatever I've shown you, it's actually correct because it's as per the truth table which I have used. Okay, as long as your truth table is used and you have used it correctly to point out in your K-maps, that's fine. So any questions? No? Okay, I give you some minutes to write down, and yeah, we have actually come to the end of the lecture. So you can copy this down and what happened? You cannot see? Come sit here. You guys can move in front. I will not eat you, okay? Come in front. This what happened? If well, for simplification purpose, I advise you combination. Okay, this is basically can suit your own needs. If the solution, it will be correct. You draw a logic diagram. Okay, but actually in order within, so the trade between your time and your, let's say, the materials which you have got. And I would have not used the KMap at all. This is just to show you what I have done. Okay? You guys are okay? Don't worry about this. Maybe you will find this in the lecture notes. So the explanation is what all is needed. Okay, guys. I think this is it for today. If you have any queries, let your course coordinator know, or you can post it in the open discussion forum which is there. Okay. See you if your lecturer is not in tomorrow.